Upthrust and Buoyancy Part 2. We know fluids exert pressure. This pressure is equal in all directions. It is measured by pressure is equal to HdG, where H is the height of the fluid column, D is the density of the fluid, and G is acceleration due to gravity. We also know objects weigh less in fluids. This is due to the upthrust or buoyant force on them by the fluid on being immersed in the fluid. This upthrust is measured as Vdg, where V is the volume of the solid immersed, which is equal to the volume of the liquid displaced. D is the density of the fluid, and G is acceleration due to gravity. Do ships float due to upthrust? Yes, ships do float due to upthrust. A ship is made up of several material, among which one are the nails. A ship is made up of hundreds of nails and it floats. What would happen if a single nail is dropped in the water? Since upthrust is acting on the ship and is making it float, upthrust should also act on the nail and make it float. But it doesn't. Why is upthrust not applicable on nail? Recall that upthrust is equal to Vdg, where V is the volume of solid immersed, which is equal to volume of the fluid displaced. Thus, upthrust is directly proportional to volume of fluid displaced. A ship is designed in such a way that it displaces a large volume of water. Hence, the upthrust on it is more. A nail displaces less volume of fluid. Hence, the upthrust on it is less. So, more the volume of fluid displaced, more is the upthrust. Let us see this with the help of another example. We see that a plate made of steel floats on water. But if the same steel plate is converted in the form of a spoon, then the spoon does not float, it sinks. The reason is obvious. A steel plate is able to displace more volume of fluid, hence the upthrust on it is more. A spoon is able to displace a very small volume of fluid, and hence the upthrust on it is less. Thus, the plate floats while the spoon sinks. Upthrust is equal to Vdg, where D is the density of the fluid in which the body is immersed. How does density of fluid affect the floating of objects? Let us study the effect of density of fluid on flotation. We shall take 3 boxes of same shape and size. Thus, their volumes are same. Since their volumes are same, they would be displacing the same volume of fluid. And according to what we have seen, since the volume of fluid displaced is same, the upthrust on them should be same. Let us first understand these three boxes are of different material having different density. The first box sinks. The second box floats under the surface of the water. The third box floats on the surface of the water. The reason is, in the first case, the density of the box is more than the density of the fluid. In the second case, the density of the box is equal to the density of fluid. In the third case, the density of box is less than the density of fluid. So, we know upthrust is equal to VdG, volume of the solid immersed, which is equal to the volume of liquid displaced. D is the density of the fluid. More the density of the fluid, more is the upthrust. And G is acceleration due to gravity. We also know density is mass upon volume. By this relation, we get mass is equal to volume into density. In our relationship of upthrust, we have volume into density. So we can write upthrust is equal to mass of the fluid displaced into acceleration due to gravity. And we have already studied that mass into acceleration due to gravity is weight. So upthrust is equal to weight of the fluid displaced. And this is Archimedes' principle. When a body is partially or wholly immersed in a fluid, it experiences an upthrust, which is equal to weight of the fluid displaced by the immersed part of the body. Thank you.